Hello, hi, how are you? Hope all of you are fit and fine, and also you are doing your study in a proper way. Today in my lecture video, I am going to explain one of the most important topics of organic chemistry for competitive exam for JEE Main Advanced, NEET, BEAT SAT, KVPY and all other national competitive examination. Today's topic is diazotization process. This is very common and we used to read this topic in haloalkane haloarine chapter first. And so far as our information is there, benzene diazonium chloride salt is the main product in this particular diazotization process. How we are getting this benzene diazonium chloride salt? When primary aromatic amine, commonly known as aniline, primary aromatic amine, commonly known as aniline, is going to react with NaNO2 and dilute HCl. And you should remember the temperature in this case is very important, and it should be 0 degrees Celsius to 5 degrees Celsius. Okay, actually what we are getting benzene diazonium chloride salt. Okay. Diazo means 2 number of nitrogen, and since it has one plus charge over this nitrogen and Cl minus, it is considered as a salt. It has a structure like NaCl, in which we are getting Na plus and Cl minus. Okay, hope it would be clear to you. Now I am going to explain one more thing. Actually, in this reaction, the main reagent is nitrous acid. That means when I am using NaNO2 and dilute HCl, actually we are getting HNO2 and NaCl, sodium chloride. HNO2 and sodium chloride, and this nitrous acid is the main reagent for the reaction. This nitrous acid is going to react with this primary aromatic amine to form our desired benzene diazonium chloride salt. And later I will explain the mechanism, then it will be clear to you. So first I want to say one thing. The reaction is going to happen at a particular temperature, and that temperature is 0 degrees Celsius to 5 degrees Celsius. And that's why this reaction is called, and the product which we are getting in this reaction is called thermodynamically controlled product. So now the question is that if the temperature is more than 5 degrees Celsius, what will happen? If the temperature is more than 5 degrees Celsius, then the benzene diazonium chloride salt is not going to form. Why? Because if you observe seriously, then you will find that this N2, the positive nitrogen, this N2, if this N2 leaves from this aromatic ring, it will be free. It will act as a neutral nitrogen. So whenever we will rise the temperature more than 5 degrees Celsius, the N2 will leave this entire species and it will be free as a neutral nitrogen molecule. So if nitrogen is not attached with the aromatic benzene ring, then what will happen? We will not get the desired benzene diazonium chloride salt. And that is why we have to remember this diazotization process is totally temperature dependent. Okay, all this information will be very effective, will be very important for the competitive exam. So many different types of short questions, MCQ questions may be formed, may be created from this part. So please listen carefully and please watch this video till end. Okay, so now what we will do, I already told you the main reagent is primary aromatic amine and nitrous acid HNO2. So now I am going to show you the mechanism, which is actually very important. What is the mechanism of diazotization process? Let's see. So first, what we will do? First, we are taking HNO2. This is, you can see, this is HNO2. This one is simply HNO2, HON double bond NO. Okay. So whenever we are dealing with nitrous acid in our medium, H plus should be there. So if we talk about H plus, we don't have any confusion. Okay, because nitrous acid is acid. We know this is a mild acid. Still, it will produce H plus. So this HNO2 is going to react with H plus. H plus. This H plus is also coming from this acidic medium. Okay. So what will happen? We can see this oxygen contain 2 lone pair of electron, and this lone pair will be donated to the respective H plus. So what will happen? What will happen? This lone pair will attack this H plus. Is it clear? So this lone pair of electron is donated to this H plus because as we know H plus is electron deficient. So it can able to take 2 electrons. So what will happen? Let's see. We are getting this thing H, O, H. This one is plus, N, double bonded O. Is it clear? Hopefully, is it clear? Okay. Lone pair donated to the H plus. H plus is electron deficient. So it can able to take 2 electrons from the oxygen. So I am getting now this kind of species. What will be the next step? Next step is the elimination of water. Okay. So how water is going to eliminate? How water is going to eliminate? This oxygen is plus. So oxygen will accept electron from this oxygen nitrogen bond. Please watch this arrow. The movement of arrow is very important. From where the arrow is coming, this is important. So what will happen? The electron present in this oxygen nitrogen bond will go towards this electropositive oxygen, means electron deficient oxygen. So what will happen? It becomes water. So what we are getting? After donating electron from this bond, nitrogen become plus. Okay. So we are getting N double bonded O and this is plus. NO plus. This is actually our reacting E plus. This is actually our reacting E plus. Okay. E plus means electrophile. NO plus is going to react with, further NO plus is going to react with primary aromatic amine, means with aniline. So nitrous acid is going to use for the production of NO plus, and NO plus is the required electrophile which will attack to the primary aromatic amine. So let's see the next step of the reaction. Okay. So what we have to do? We have to take the primary aromatic amine. Whenever you are taking the note, you just pause your video and then write it down. It will be good for you. So now we are trying to write the entire reaction, the end step. So what will happen? We are taking this aniline, primary aromatic amine, NH2 attached with this benzene ring, and already in our hand NO plus is there. We have seen it. Okay. So this aniline is going to react with this NO plus. Clear? We can write it in a better way. N double bond O and positive charge is there. So it is simply an electrophile. What will happen? Everybody will know nitrogen has lone pair of electron, and in this NO plus the nitrogen is positive, electron deficient. So definitely what will happen? This lone pair will be donated towards this nitrogen plus. So this will be donated to this. Clear? So now what we are getting? We are getting this thing, benzene, nitrogen of aniline, H, and one more thing, another nitrogen and double bonded oxygen. This is a structure after adding this NO plus towards the primary aromatic amine, and this nitrogen having 4 bonds should have a plus charge. Is it clear? So now what will happen? Now positive nitrogen is not so stable, so there will be the elimination of H plus. Clear? So H plus elimination should be there. How H plus means proton is going to be eliminated? Okay, this bond, this nitrogen hydrogen bond will donate electron towards the electron deficient nitrogen. What will happen? The nitrogen hydrogen bond, from this nitrogen hydrogen bond, electron is going to donate to this N plus. After that, what will happen? We are getting this thing, the benzene ring, this is the important thing, and this benzene ring is attached with the nitrogen already having one hydrogen, the left hydrogen is there, okay, the left side hydrogen, and this nitrogen is attached with single bonded nitrogen and double bonded O. Clear? I hope the entire process is very clear to you. Clear? So the first step is the addition of NO plus, then elimination of H plus. After that we are getting this. Clear? So what would be the next step? Next step is very interesting. What will happen? Minus plus H plus, some sort of tautomerism. Clear? So what will happen? We are getting this thing after tautomerism. This is the tautomerism symbol, you know, minus plus H plus. What is the meaning of minus plus H plus? First elimination of proton. What is the meaning of plus? Then addition of proton. Means first elimination, then addition of proton. So what will happen? Now we are getting this thing. The nitrogen hydrogen bond will donate electron here, and the double bond is going to open. The double bond, nitrogen double bond is going to open. So what we are getting? We are getting this thing. You can see nitrogen, double bonded nitrogen, OH, this is very clear, and this nitrogen is attached with benzene ring, aromatic ring. Is it clear? This nitrogen is attached with benzene ring. Now it is clear, I hope. Is it okay? So after elimination of hydrogen, the hydrogen is going to add it to this oxygen. That's why I told you first elimination, then addition. So now I am getting this thing. And after that, what will happen? In our medium, lots of H plus is there. I already told you in acidic medium, always H plus is there. So what will happen? This H plus is going to attach with this electron rich oxygen. Clear? This portion. H plus is going to attach this OH. So what will happen? Now we are getting this thing. This is the benzene ring. And nitrogen, double bonded nitrogen, and OH2 plus. Clear? After adding H plus, the OH becomes OH2 plus. So we are getting this thing. Now in the last step, just before we are getting that benzene diazonium chloride salt, what will happen? Water is going to eliminate from the system. So now what we are getting? We are getting this thing minus H2O. Minus H2O. Clear? So from where the water is going to eliminate? It has lone pair of electron. Nitrogen has lone pair of electron. So it will donate here to make it triple bond. And this OH2 plus is going to eliminate. It's okay. So in this way, what we are getting? We are getting this thing, benzene ring. This is the benzene. Clear? And along with this, we are getting N, triple bonded N, and this is a plus. And in our medium, when I use in the first reaction NaNO2 and dilute HCl, we have HNO2 and NaCl. So in the medium, Cl minus is also there. Okay, and this Cl minus is going to attach with this positive entity to provide the desired benzene diazonium chloride salt. So this is the entire mechanism, and this mechanism is very important. So this is my request. Please watch this video and write it down in your pen and in your notebook, and it will be beneficial. And this is my request. If you have any feedback, any kind of feedback, please write it down in the comment box. Okay, all the best. Hope see you soon. Bye.